You're welcome to today's meeting. Today we are going to look at another aspect of linear equation that involves absolutes. And after that, we move on to word products. So by the end of today's meeting, you should be able to solve linear equations involving absolutes, formulate linear equations from word products, and then solving the formulated linear equations. So let's move on to linear equation involving absolutes. Now let's consider absolute AX plus B equal to C, or modulo AX plus B equal to C. Now this symbol is called the absolute sign, or you can call it the modulo sign, or the modulo. So if you have absolute AX plus B equal to C, where A, B, and C are constant, they are real numbers. It means we have only X being the variable with the power 1. Hence, it's a linear equation. So, to solve an absolute equation AX plus B equal to C, we have to split this equation into two. Now, what we'll take note before we move on is that the absolute sign means every real number should change to positive. So in case a number is negative, it should change to positive. Maybe it's positive, it's positive. Example, if you have absolute 5, it's equal to 5. If you have absolute negative 5, it's equal to 5. If you have absolute 20, it's equal to 20. If you have absolute negative 20, it's also equal to 20. So this sign is telling you that we want the actual value, not any sign against it, the actual real number. That's the meaning. So to solve this equation, we have to split this equation into two to get three linear equations. Equation 1 is obtained by just removing the sign. So I said split the equation into two as AX plus B equal to C to get one of the equations. Then to get another equation, we can choose to negate the left side or the right side. Negating means you can multiply the left side through by -1 or the right side through by -1. So you are negating whatever you have, the left or the right, as we can see here. So this time I have negated the left side. So we have negative into bracket AX plus B. And this negative will change the sign of AX and B at the left side. So negative into bracket AX plus B equal to C. Or I can choose to negate the right hand side to get AX plus B equal to -C. So here the negative is at the right hand side to get your equation 2. So after getting your two equations, then you're going to solve each one of them. Even though there are two equations, you're not going to solve them simultaneously, but you're going to solve them one after the other to get two solutions. You have learned how to solve linear equations, so we shouldn't get the problem here. So note absolute A equal to plus or minus A. That's absolute A equal to A and absolute negative A equal to A. Example. Solve the following equations. The modulo 2x plus B plus 5 equals 3. Modulo 4x plus 9 equals 3x minus 2. Modulo half x minus 4 equals 5x minus 4. IV modulo x minus 6 equal to modulo 2x minus 7. So let's see how you can solve them. So the first one, I. You see that we have this equation, we have to get two equations out of that. So first we have to remove the sign to get one equation. To get equation 1 as 2x plus 5 equal to 3. Now you can negate either left or the right. So this one negated the right hand side. So we negated the 3 to get negative 3. Therefore equation 2 is 2x plus 5 equal to negative 2. Or you can choose to negate the left hand side as this. So now that we have the two equations, we can solve them one after the other. So let's solve equation 1 first. 2x plus 5 equals 3. So we cannot send the 5 to the right hand side to become negative 5. So 3 minus 5 is minus 2. So we have 2x equal to minus 2. Divided through by 2, we have x equal to minus 1. And this we know how to solve linear equations. So after getting your solution for equation 1, then you move on to solve equation 2. Equation 2 is 2x plus 5 equal to minus 3. In the same way, send the 5 here, we get 2x equal to minus 8 because it's minus 3 and 1 5 can become also minus 5. So minus 3 minus 5 which is minus 8. Now by dividing through by 2, get x equal to negative 4. Therefore, the solutions are x equals minus 1 and minus 4, or x equals minus 1 and x equal to minus 4. I hope you are getting it. Let's the I. The same manner, let's remove the symbol to get first equation as 4x plus 9 equal to 3x minus 2. Now we negate any side, so we have negated the left side. So we have negative into bracket 4x plus 9 equal to 3x minus 2 to get two equations. So let's solve them one after the other. So from equation 1, we can group like this. So I'll send the 3x to this side. Check the sign here, positive when it can become negative. Now it's going to the right side, and the sign here is positive when it goes to become negative. That's what you see here. So by simplifying, we have 4x minus 3x is x equal to minus 2 minus 9 minus 11. Solving the second equation. Because we are negative here, it means we now multiply 4x by minus 1, 9 by also minus 1. So the sign here will change. So here become negative, here become negative. That's the meaning of negating. So see the equation having minus 4x minus 9 equal to 3x minus 2. Then we group like this. So we have minus 4x minus 3x equal to 9 minus 2. So by simplifying, we have minus 7x equal to 7. Hence, divided by minus 7, we have x equal to minus 1. So we are now getting the two answers as x equal to minus 1, x equal to minus 11. Good. The next example, we have absolute half x minus 4 equal to 5x minus 4. So we can, as usual, we have to remove to get one equation. So we have equation 1 of this, half x minus 4 equal to 5x minus 4. Now equation we have negated the left side, we can also equally negate the right side. So this side we have the left side being negated. So minus into bracket half x minus 4 equal to 5x minus 4, equation 2. Solving each one of them. So equation 2, we have a linear equation involving flashing. Therefore, we can choose to multiply through by the LCM, which now is 2. So multiply here by 2, here by 2, here by 2, here by 2 to get rid of the flashing. So by doing so, we are not going to get this. Therefore, 2 times half x becomes x. 2 times 4, 8. 2 times 5, 10x. 2 times 4, 8. So you cannot do like this to get this time. I send 8 to the left side and x to the right side. So I got minus 8 plus 8. Now 10x minus x. And that will give me 0 equal to 9x. So divide through by 0 by 9, we are not going to get x equal to 0 over 9, which is 0. So let's solve equation 2. Like equation 2, we also have minus half x plus 4 equal to minus 5 minus 4. If we have to negate the left side, so we have negated the left side. So they say by multiply 2 by 2 LCM, you are not getting minus x plus 8 equal to 10x minus 8. So group like terms, we have 8 plus 8 equal to 10x plus x. You should know why. The sign here put negative, so when you cancel negative, you can positive. X is negative, when it goes to become positive. So by simplifying, we have x equal to 16 over 11. The last example, we have an absolute or the modulo at both ends, both sides of the equation. By the same principle, whether you have only one modulo or two at each side of the equation, we still follow the same principles. So getting equation 1, we remove the modulo signs from each side to get equation 1. Now getting equation 2, we negate one side of equation 1 as usual. So don't think because we have two modulo here, then we negate here, we take this side and we take the process, and then after that we also take the left side also left. No. If there we have the two sides or two modules on each side, remove them to get one equation and then negate one side as we did when you have only one module. So now having equation 2 here, two equations here, you cannot solve them as usual. So by grouping like terms, so we have minus 6 plus 7 equal to 2x minus x. You know why? This one goes 7 coming to the left side, x going to here. And that will give me x equal to minus 1. So solving the equation 2, you have minus x plus 6 equal to 2x minus 7. And that will give us x equal to 13 over 3. So you can try these examples if you don't have any problem. You can try these examples. So there are 4 examples. We'll try them. Good. So let's now move on to how to solve word problems. All what we have done, equation was given, and we had to solve the equation. Or from the last 2 weeks of meeting, the points will be given, you get formulate the equation for the points, and then you solve it. This time around, the problem will be in the word form. So we are going to formulate the equation from the word form and then you solve it. That's what we call the word problems. So at the end of today's meeting, to solve the word problem, then students are expected to formulate linear equation out of the word problem and then solve the problem. So let's see the steps involving when solving the word problem. 1, you have to read the problem carefully because it is statement form. So for you to come out with anything meaningful, you have to understand what is written. So you have to read the statement carefully. Then as you are reading, you will be identifying some unknown quantities. So after identifying them, then you just represent the unknown quantities by variable. So after you have done that, then you are now going to break the problem into small pieces. So we are going to represent each piece by an algebraic expression. After that, we are now going to arrange the algebraic expressions into equations. And then after getting the equation, you solve the equation, and then you check your solutions in the word statement. So let's move on to see how we can solve such equations. So example 1. If 4 times a certain number is equal to twice the sum of 5 and that number, find the number. If 4 times a certain number is equal to twice the sum of 5 and that number, find the number. So here you cannot identify that we have to find a certain unknown number, the number that we don't know. So unknown quantity. So we have to find a certain number. So if 4 times that number, so if you are multiplying that number by 4, the answer is equal to twice in 2 times the sum of 5 and that number. So let's see how we can now break them into pieces. So let's represent the unknown quantity by x. So they let x equal to the unknown number. And after this, let's go. So we know the unknown number here, a certain number is x. So we know if 4 times x. So it means 4 times the unknown number x is 4x. 4 times. Now I know the unknown number is also x. It's equal to twice the sum of 5. The sum is addition. So the sum of 5. So the sum of 5 and that number. So 5 plus that number. So we have another piece. The sum of 5 and the unknown number is 5 plus that number. So let's see if we can join them by using the equal sign. So let's go back to the statement again and then introduce our equal sign. If 4 times a certain number is equal, so 4 times a certain number is 4x is equal. So we have now brought the equal sign, equal to twice. Twice means 2. Twice the sum of 5 and that number. The sum of 5 and that number is 5 plus x. So to me, we are now joining the two algebraic expressions to get the equation. So we have 4x equal to twice, so 2 times 5 plus x. I hope you are getting it. So we have to break it down into small pieces. And after that, we try to see if we can join them. So now that we have a linear equation, we can now go ahead and solve this one. So by expanding, we have 4x equal to 2 times 5, 2 times x. We have 10 plus 2x. So grouping like terms and simplify, the 2x equal to 10. Then x equal to 5. So if x equal to 5, let's see if it's true. So checking the solution. Substitute x equal to 5 into the equation. So 4x, which is 4 times 5 equal to 2 into bracket 5 plus 5. X is 5. So that will give me 4 times 5 is 20 equal to 5 plus 5 is 10. 10 times 2 is also 20. So it means that number is 5. So let's move on to example 2. The sum of 3 consecutive integers is 303. Find the numbers. Now we are talking about the integers. We know integers, they are positive and negative whole numbers, including 0. So it means we go to number line, we have positive side, we have 1, 2, 3, 4, 5, 6, 7, 8 going. So in case if you do a number line, if you're on one integer, if it's 1, then for you to move on to the next integer, you have to jump one step to get to the next integer. So 1, you move on to one step, you get 2. You move another step, you go to the next one, 3. You move one step, you get 4, and so on. So it means whenever you are on any integer, to get the next integer, that would be called the consecutive. So to get the next integer is by adding 1 to the number that you have. So if my integer is 10, to get the next integer, the next consecutive integer, you can 10 plus 1, I'll get 11. The next one becomes 11 plus 1, I get 12. 12 plus 1, I get 13, and so on and so forth. So if you are talking about consecutive integers, we mean the integers that follows in their natural order. They are consecutive integers. So from one integer to the next integer, we have to add 1. So we don't know that if you go back to the question says that the sum of 3 consecutive integers. So it means we don't know that 3 integers. Therefore, let's represent the first one by x. Let's say if x is 20, to the next one becomes 21, 22, and so on. So if x is 20, the next one is 20 plus 1 is 21, the next one becomes 20 plus 2 is 22. Good. So let the first one be x, so the next one becomes x plus 1, and the next one becomes x plus 2. That will be the consecutive integers. So you have the 3 algebraic expressions here. Now let's go back to the question and see what we should do to them. The question is the sum. The sum means we have to add them. So the sum of 3 consecutive integers means we have to add the 3 consecutive integers. Yes. So to me, we add them, we are not going to get the answer to the 303. So therefore, by adding them, then we have x plus 1 plus x plus 2 equals to 303. So by adding the variables, we have x plus x plus x with 3x. By adding the figures, we have 1 plus 2, which is also 3. Now equal to 3. So here we cannot solve the linear equations here. By sending 3 here, we have 3x equal to 300. Dividing by 3, we have x equal to 100. So if the first one equal to 100, as we got in here, the next will become 101. The next will become 102. Because we have x here to be 100, so here is 100 plus 1, 100 plus 2. So we are now getting our 3 consecutive integers. Good. So let's see the next example. The average of 4 consecutive even numbers is 87. Find the difference between the smallest number and the largest number. Find the difference between the smallest number and the largest number. So before then, now let's find the numbers and then we move ahead. So the average of 4 consecutive even numbers. Now when you go to the integers or whole numbers, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going. So among them we have the even numbers and we have odd numbers. We know even number is any number that 2 can divide it exactly. Or 2 can divide the number with that a remainder. So that number is called an even number. So when you divide any whole number by 2 and they get a remainder or decimal, it is that number is odd number. So even numbers we now have, let's say, 2, 4, 6, 8, 10, 12, and so on and so forth. And the odd numbers are 1, 3, 5, 7, 9, 11, 13, 15, and so on and so forth. So you see that if you're on the number line, when you're on the even number, the next one becomes odd. Then we move from even, odd, even, odd, even. So if you want to get the consecutive even numbers, it means you have to jump 2 times to get the next even number. So imagine I'm on 8. When I move to the next one, I'll get 9, which is odd. Then I move next, I'll get 10. So I'll move again, I get 11 and then 12. So whenever you move 2 times on the number line, If you are the even number, you get the even number. If you are the odd number, you get odd number. Don't forget that. Hence, it means therefore that if I'm having even integers, before I move on to the next consecutive even integer, I must add 2. Don't forget the last example was integers. So they are even and then odd. But this time we are talking about the even integers. So even integers means before on the number line, before you move one even number to another even number, you have to move 2 steps. It means you have to add 2 to whatever even number that you have to move on to the next even number or the next consecutive even number. If you are on the odd number, for you to move on to the next odd number, you must also move 2 steps before you move to the next odd or next consecutive odd number. So assuming the even number is, let's say, 20, the next one becomes 20 plus 2, which is 22, the next to 20. 23 plus 2, which is 24, the next to 23. So whenever I add 2 to an even number, I get the next even number, which are consecutive even numbers. And the same thing applies to odd numbers. So let's go to the question again, statement again. The average of 4 consecutive even numbers. So first of all, let's find the numbers before we talk about the average. And the numbers, there are 4 of them. They follow their natural way, and all of them are even numbers. So let the first number be x. So as I told you, the next one will add 2 to x. I'll move on to the next even number. Add 2 to x plus 2. I'll move on to the next even number, which is x plus 4. If I add 2 to x plus 4, move on to the next even number, which is x plus 6. Hence, my numbers are 2, x plus 2, x plus 4, and x plus 6. So with this algebraic expression, now let's go back and see if we can join them to get the equations. The average means add all the numbers that you have together and divide by the total number of items or numbers that you have. So how many are there? 1, 2, 3, 4. To me, we are going to add all and divide by 4. Now difference means subtraction. So it means if we add all, we divide by 4, we get the average. So if we go back to the question statement, the average of 4 consecutive even number is 87. So it means if I add all the numbers divided by 4, it should give me an 87. So by simplifying the cross multiply, or multiply by the LCM, the fraction, so the LCM is 4. So multiply here by 4, this side also by 4. And that will give me 4x plus 12 equal to 3, 4, 8. Add the variables and then the figures. You get 4x plus 4. 4x plus 12 equal to 3, 4, 8. Put the linear now, so you can answer this one to get x equal to 84. So the first even number we are talking of is 84. Therefore, 84 plus 2 is 86. 86 plus 2 get 88. 88 plus 2 get 90. And these are the consecutive even numbers. The question is if you find the difference between the largest and the smallest. Now with this, even if the question is objectives, the largest, the smallest x, and the largest is x plus 6. So we could have also found the difference by subtracting the x from x plus 6, which will be x plus 6 minus x. And then the answer will be 6. But once the theory, you have to find the numbers and then you subtract. So now the smallest number is 84, the largest is 90. So therefore the difference between the smallest and the largest is 90 minus 84, which is the same as 6. I hope you are getting it. Good. Now example 4. The average of 5 consecutive odd numbers is 181. Find the product between the largest and the smallest number. Find the product between the largest and the smallest number. So this time we are talking about odd numbers, and it follows the same process as even numbers. So I've already told you yesterday. When you're on the odd, you move for the next odd, you add 3. So when you're on 3, 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9. So the unknown number here, or numbers here, we don't know them, so let's represent by a variable which is x for the first number. The next one becomes s plus 2, s plus 3, s plus 6, and s plus 8. So if you want to subtract them, get different 2, 2, 2, 2, 2. So s plus 2 minus x, you get 2. S plus 4 minus s plus 2, you get 2, and so on and so forth. So after getting your algebraic expressions, which are now 5, let's go back and then join them to get the equation. The average, you know it, the average means we sum them up and divide by total number of items. This time they are 5, so we divide by 5. So let's add all of this and divide by 5, as we have here. Now the LCM is 5, so multiply here by 5, here also by 5. So we are not going to get 5x plus 20. Let's add the variables under the figures, equal to 905. So this is a linear equation. You can solve that to get x equal to 177, which is odd number. So 177 plus 2, you get 179. 179 plus 1, 2. 179 plus 2, we get 181. 181 plus we get 183, and so on and so forth. So this should change. The 177, 179, 181, 183, 185. So let's move on. I'll make that correction for you. So the product of the largest and the smallest is 177 and the largest 185. So 185 times 177, the answer is 32,745. So that's the answer. Let's move on to the fifth example. At this time, we're not moving away from numbers, we're talking about the ages. So let's see. The ages of a mother and her daughter are such that the mother is 4 times older than her daughter. In 5 years' time, the age of the mother will be twice her daughter's age. Find their ages. So now let's go slowly and try to break them into small pieces. But what we're talking about, the unknown thing here, the age of a mother and her daughter. We don't know. So let's represent maybe x by the daughter's age, or x by the mother's age. So I just have taken the smaller age or the younger one. So let's go back and see. The ages of a mother and her daughter are such that the mother is 4 times older than her daughter. So it means if the x in the daughter's age, when I multiply 4 by x, I'll get the mother's age. How we are getting it? The mother's age is 4 times her daughter's age. The mother's age is 4 times her daughter's age. So if the daughter is x, then the mother becomes 4x. If the mother is x, the daughter becomes, we divide the mother's age, and we are not going to get the daughter's age. So we said let x equal to the daughter's age. Then the mother's age, present age, now will be 4x. So we are now here. Now let's continue. In 5 years' time, so let's get their ages in 5 years' time. So in 5 years' time, if all things be equal and all of them are living, it means the mother's age is going to be increased by 5. The same way the daughter's age will also be increased by 5. Because all of them will get 5 years in addition to their present ages. That's the meaning, in 5 years' time. In case you are 20 years now, By 5 years time, you'll be 25. You add the 5 to your present age. So if the mother is X, 4X, in 5 years time, the mother's age becomes 4X plus 5. And if the daughter is now X, 5 years time, the daughter will also be X plus 5. So that's what you see. So you have their present ages and now their ages in 5 years time. So the two of them. So their current ages are X and 4X, respectively for the daughter and the mother. Then their 5 years time, the future age or ages will be 5 plus X, 5 plus 4X, or X plus 5, 4X plus 5. How we are getting it? So we are not going to talk about these algebraic expressions, but let's go back to the statement and see if we can join them together. The ages of a mother and her daughter are such that the mother is 4 times older than her daughter. In 5 years' time, we are now concentrating on the 5 years of the ages in 5 years' time. So in 5 years' time, the age of the mother, which is 4x plus 5, will be twice. Twice means 3 times. Twice, 3 times, twice, 2 times. So will be twice her daughter's age. So it means in 5 years' time, the mother's age will be 3 times the daughter's age. So this is how we are joining them together. Let's go back to that point again. In 5 years' time, so it means you are not even your 5 years ages, the future ages. In 5 years' time, the mother's age, which is 4x plus 5, will be equal to twice, 3 times her daughter's age. So we are not going to have 4x plus 5, but 3 times the daughter's. So the mother's age in 5 years will be 4x plus 5, will be twice her daughter's age, which is x plus 5. So we are not be able to join them together to get a linear equation. And when we solve this, we are not going to get x equal to 10. Good. So the daughter is 10 years now. Now the mother will be 4 times 10, which is 40 years. So currently the mother is 40 and the daughter is 10 years, which is blue. So during 5 years time, now here, 5 years time, the mother will be 40 plus 5, is 45, and the daughter will be 10 plus 5, which is 15. So divide 45 by 50, you're not going to get 3. So that twice the daughter's age. Good. Next example. AC and Equia are very close friends. Their ages are such that AC is 3 years older than Equia. In 6 years ago, AC was twice as old as Equia. How old are they? So here, let's see if we can now also get the algebraic expressions out of that. But we are talking about unknown ages. So let's represent the age of Equia and AC by variable. So also we want to link them to get one equation. So we can now find the age of the smaller or the younger friend. So we are saying that AC and Equia are very close friends. Their ages are such that AC is 3 years older than Equia, means the Equia the younger. So if you know the Equia's age, so we can say let x equal the Equia's age now. Now since Equia's age is s, AC is 3 years older than Equia. It means if I add 3 to the Equia's age, I'm not going to get AC's age. Or if I know AC's age is s, if I subtract 3 from it, I'll get Equia's age. So which other way we can choose to solve that? So let's see to get their ages in 6 years ago. In 6 years ago means 6 years back. So assuming you are 10 years now, in 6 years ago, you were somewhere 4 years. You have to subtract the 6 from your current ages or age. I hope you are getting it. So in 6 years ago, so it means in 6 years ago, if currently AC is x plus 3 and equals is in 6 years ago, AC's age will be 3 x plus 3 minus 6. That will give me x minus 3. And Aquarius age calendar is x. So 6 years ago, Aquarius was x minus 6. So to get their ages in 6 years ago, how we are getting it? So their present ages, they will subtract 6 from each one's age. And by this, we have two automatic expressions. So now, let's see if we can join them by going back to the statement from 6 years ago. So in 6 years ago, 80 was twice. So 6 years ago, 80's age is x minus 3 equal to twice. Twice means 2 times the Aquarius age. And the Aquarius age is x minus 3. So we have x for the 80's age, x minus 3 equal to 2 times Aquarius age, which is x minus 6. So we can expand to get the linear equation. We have the linear equation here. So by expanding and solving, we are not going to get their ages. So by the we have x equal to 9, it means Aquarius is 9 years, calendar Aquarius is 9 years, and AC will also be in 12 years. How we are getting it? So in 6 years ago, Aquarius was 3 years, and AC was also 6 years. So you can see that 9 is the correct, 9 and 12 are the correct answers. Good. Now at times, we have a question that you have to solve them simultaneously. Even though all the previous examples, some of them you could have solved them simultaneously. Like the ages. You can also get a create age. You give a different variable from the AC's age. So you get two different equations, you can solve it simultaneously. But then we can link them up to get just one equation. That's why we just find the link between the two and then we use only one variable. But this time, some of them we cannot do that. So problems that lead to simultaneous equations. We have that simultaneous equation, so this will not have the problem here. But let's see how we can do that. Kofi bought 6 textbooks and 10 calculators from a store. Amma also bought 3 textbooks and 22 calculators from the same kind from that store. If each of them paid 17,000 Ghana cedis for their items, total items. Now, if X represents goods and Y represents calculator. Write down 2 linear equations connecting X and Y. Find the cost of each book and calculator. I hope you are getting it. So you went to the market and then you have the goods and the calculators. You bought them. And in all you paid 17,000. Your friend also bought goods, a set of goods and calculators. He or she also paid 17,000. So let's find the cost of each book and then each calculator. So we are now representing the X. This time you are lucky that you have the variable being represented by the unknown thing. So we are now represented by X by the goods and then Y by a calculator. So let's go back to the statement and see if you can form the equations. So form the one for Kofi and the other one for Aman. Kofi bought 6 textbooks. So textbooks is X. So we have 6X and 10 calculators. So Kofi is having 6X plus 10Y. Because Y is calculator, X is books. So Kofi bought 6 textbooks. So it means 6 times X and 10 calculators. 10 times Y. And he paid 17,000. So to me, one of the equations is 6x plus 10y equal to 17,000. So you can further simplify this one because you know that 2 can go here, 2 can go here, 2 can. So you can leave it as it is, or you can simplify it by dividing it by 2 to get this equation 1. Now let's go to form equation for Amber. Amber also bought 3 tables. We have 3x and 22 calculated, so 22y. So that will give me Amber's equation as 3x plus 22y equal to 17,000. Because the question is they all paid 17,000 Ghana cedis. So we're now having our 2 equations. So the question is if she find the cost of each capital and the textbooks. So we have 2 simultaneous equations. 3 equations can solve them simultaneously. Now we have done how to solve simultaneous equations. So whether you're using elimination or substitution. So this I won't solve it for you, but I've given you the answer. So go through the processes. So we have equation 1, we have equation 2. Now look at now if you have 3x, 3x here, so we know what you do in case we are using elimination method. So by solving them, then one textbook is called 2,000 and calculator is called 500 Ghana cedis. So the cost of each book and the calculators are 2,000 Ghana cedis and 500 Ghana cedis respectively. So I've written it. Please go through the processes we have said. Example 3. The cost of a bag of millet is P Ghana cedis, and the cost of a bag of sorghum is K Ghana cedis in Takla the market. If 30 bags of millet and 40 bags of sorghum cost 12,700 Ghana cedis, and if 40 bags of millet and 30 bags of sorghum cost 13,900 Ghana cedis. Write down 3 linear equations concerning P and Q. Hence, find the values of P and Q. So this time when you go to the market, you are buying the millet and the sorghum. Now you know the price of 1 millet, the cost of a bag of millet. So the price of 1 millet is P Ghana cedis. So this time we are talking about the prices of the millet and the sorghum. And the bag of a sorghum is K Ghana cedis. So let's see what you do. So if you buy 30 bags of millet, what are you going to pay? You multiply 30 bags by 1 cost of millet, which is P, to get it 30p. And 40 bags of sorghum. So it means you are not going to multiply the 40. You buy 40 bags and 1 bag is K Ghana, so you multiply K by 40. So you have 30p plus 40 K. And in all, you paid 12,700 Ghana cedis. So that will give us equation 1. The next one you bought 40 bags of millet. So it means the 1 cost of millet is 50p. Therefore, in the 40 bags of millet, you are not going to pay 40 times P with 40p. And now 30 bags of sorghum also 1 is K. So multiply 30 by K. And in all, you pay 13,300 Ghana cedis to get the 2 equations. So I've explained everything here. 30 bags of millet cost 30p, 40 bags cost 40k. So one of the equations is 30p plus 40k equals 12,700. We can just go through them, simplify them, divide through by 10. 10 goes here, 10 goes, 10 goes to get equation 1. Now 40 bags of millet is 40p, 30 bags of sorghum is 30k. So by also adding that to get the equation, get 40p, 30k equals 13,900. You can also divide through by 10, 10 go 10 to get equation 2. So you have the 2 equations at this, or you can still get your original equation at this and that. So we are having 2 equations, you can solve them simultaneously, either by elimination or substitution. So solve them yourself. The answers when you solve them will give you a bag of millet is 250 Ghana cedis and a bag of sorghum is 130 Ghana cedis. But you have to go through the process yourself. So I've given you some questions to try your hands on, and there are 4 of them. So try to solve each one of them. If you have a problem, you can let me know. I hope everything's okay. So thank you for coming. Let's meet the next time.